Item 51. The coordinate of the turning point of y equal 4x minus x squared are. The turning point of this graph is going to be the maximum value or the highest point on the graph, which is going to be at this point here. Now, in order to get the coordinate, you need to read the x value. So if I draw a straight line from here going on to the x-axis, that will give me 2. And if I draw a straight line going horizontal, going towards the y-axis here, that will give me 4. So therefore, the turning point is going to be 2, 4. So our answer is going to be D. Item 51. Which of the following pairs of lines are perpendicular? Now, one fact that you should always remember about perpendicular line, the product of their gradient is equal to -1. So therefore, M1, which is gradient 1, multiplied by gradient 2 is equal to -1. Right? So what we're going to do, we're going to observe our option, and whichever pair of equations satisfy this condition, that means that pair of equations are perpendicular lines. Now let's look at C here. Note that C, the first equation, is written in the form y equal mx plus c. So C is going to be y equal minus 4x plus 10. Right? The second equation is 4y equal x plus 1. What we're going to do is to write this equation in the form y equal mx plus c. In order to do that, we need to divide each term here by 4. If we divide each term by 4, then we are going to get y is equal to 1 over 4 x plus 1/4. Now, the gradient of both lines is the coefficient of the x term. So here, the gradient of this line is going to be -4. And the gradient of this line is going to be 1 over 4. Now, if both lines are perpendicular, then when we multiply their gradients, we should get -1. So let's do that. So it's going to be -4 multiplied by 1 over 4 -4 times 1, that's going to give us -4 over 4, and -4 over 4 is the same thing as -1. So therefore, our answer is going to be C, because it satisfies the condition. So perpendicular lines, the product of their gradients is equal to -1, or you could say one is the negative inverse of the other. So the gradient, one gradient is the negative inverse of the other. Let's take a quick look at option B. Option B could not be the answer, but there is something important happening about option B. Note here the gradient of this line is 2 and the gradient of this line is 2. Whenever two lines have the same gradient, they are said to be parallel lines. So parallel lines have the same gradient. What's a point for you to note? Item 53 refers to the following diagram of a transformation, and here is the transformation. 53. What transformation maps PQR onto P prime Q prime R prime? Is it an enlargement? No, so A is not the answer. Is it a rotation? No, so B is not the answer. Is it a cancellation? No, so C is not the answer. Is it a reflection? Absolutely yes. So D is the answer. Item 54 refers to the following diagram of an isosceles triangle, right? In the triangle, the value of x is, now in an isosceles triangle, it has two equal sides and two equal angles. So this angle here is 30. It means that this angle here is also 30 degrees. Now, the sum of the interior angle in any triangle adds up to give 180 degrees. So here we have 30 degrees plus another 30 degrees. That's going to give us 60 degrees. So therefore, 60 plus what value gives us 180 degrees? That's going to be 120 degrees. So x is 120. So our answer is going to be C. Item 55 refers to the following transversal diagram in which the line AB, which is this line AB, and CD are parallel, right? 55. Which of the following best describe the relation between x and y? Right? So there is angle x, here is angle y. The first option, so A is not the answer. B, x is equal to y, yes. And the reason for that is angle x and angle y is what we call z angles or alternate angles, and our alternate angles are equal. Alright? Item 56 refers to the following pair of similar triangles. And here we have one triangle which is ABCD, and the next one is MON. The length on MO in centimeter is, now one thing about similar triangles, we can use ratio and proportion, right? So we can ratio the similar side. So here we have AB, so we're going to ratio AB to MN, so it's going to be MN, and that is going to equal to AC, which is AC here, over MO. Now what we're going to do is to substitute the length for each side. So AB is going to equal to 6 divided by MN, that's going to be 3, equal to AC, that's going to be 7 over MO. That's what we want to find. Now 6 divided by 3, that's going to give us 2, is equal to 7 over MO. If we want to find MO, what we're going to do is to multiply both sides by MO. And if we multiply both sides by MO, we're going to get 2 MO is equal to 7 And then what we're going to do, we're going to divide both sides by 2 because we want MO by itself. So 2 divide 2. Therefore, MO is equal to 7 over 2. And 7 over 2 as a decimal is going to be 3.5. So our answer is going to be C. Item 57. The image of a point P, 1, 2 under a translation is P prime, -5, -4. What is the translation vector? Now, if we have a vector, right? And what we're going to do is to rewrite these vectors as column vector. So if we have the vector OP, the vector OP plus the translation vector, and in this case we don't know the translation vector because that's what we want to find. So let's use TV for translation vector must equal to the image, and the image in this case is going to be OP prime, right? So the image vector. So therefore, OP as a column vector is going to be 1, 2. Let's say that the translated vector is going to be X, Y, because we don't know it. And it's going to equal to the image vector, and as a column vector, it's going to be -5, -4. So in order to find the translated vector, we must subtract the vector OP, right, from both sides. So it's going to be X, Y, which is the translated vector in this case, is going to equal to the image vector, which is -5, minus the original vector, which is OP in this case. So what we're going to do is to just subtract corresponding elements. So it's going to be -5 minus 1, and then it's going to be -4 minus 2. So therefore, XY is going to equal to -5 minus 1, that's going to be -6. And -4 minus 2, that's going to be -6. So a translation vector is going to be -6, -6, and that option is A in this case. Item 58 refers to the following diagram, and here we have an enlargement. Now 58, OAA prime, comma, OBB prime, and OCC prime are straight lines. triangle ABC is mapped onto triangle A prime, B prime, C prime by an enlargement with center O. What is the scale factor of the enlargement? Now, the scale factor of the enlargement can be found by ratioing the image length over the corresponding object length, right? So any one of the sides you can pick. So here, if you look at the image, the image is A prime, C prime, right? And as you can see, this length is going to be 4, right? Because we have 1, 2, 3, 4. Now the object length is going to be 1, 2. So object length is going to be 2. So therefore, the scale factor, which I'm going to use SF for scale factor. So the scale factor is going to equal to the absolute value, which is the length of A prime, C prime, which is going to be 4, divided by AC, which is 2. And 4 divided by 2, that's just going to equal to 2. So therefore, the scale factor is 2. And our answer is going to be C. Item 59. A plane is flying in a direction of 045 degrees and change course in a clockwise direction to 135 degrees. The angle through which the plane turn is, now the angle through which the plane turn is going to be 90 degrees, which is B. But let's look at this in a graphical perspective. Now, let's say the plane was traveling from point A, which is this point here. First thing we need our north line, right? So this is our north line here. And from north, the plane was traveling at an angle of 0.45 degrees. So let's say 90 degrees is here. So 45 degrees is going to be halfway between. So the plane was traveling on this part, going in this direction, right? So from north to this line, that's 0.45 degrees or 45 degrees, right? Then the plane changed course to now 135 degrees. So let's say that it reaches this point. Here we need a north line, right? Again to show. And from north, we need 135 degrees. So let's say north, this is north. That means this line here would be south. So 135 degrees is going to be somewhere around here. So the plane is now going in this direction, right? So that means the angle from north to this direction, that's going to be 135 degrees. Now what we want to do is to determine the angle, right, that allow the plane to change direction. So remember that the plane was already traveling 45 degrees and then now it reaches 135 degrees. So it's going to be a difference between 135 minus 45. That's going to give us 90 degrees. All right. To our final question. Item 60 refers to the following diagram, not drawn to scale, which shows that the angle of depression of a point X from Z is 30 degrees, right? And this is the angle of depression, this 30 degrees here. Now 60. If X is 10 meters from Y, the height of YZ in meter is, so we want to find this height here, which is YZ. Now we know the length of XY, right? So here, do we know this angle here? Yes, we can determine this angle. The angle of depression is equal to the angle of elevation. So therefore, this angle is going to be 30 degrees. Or you could say that alternate angles are equal, or Z angles are equal. So now we know that this angle is 30 degrees. Now let's label our triangle in relationship to this 30 degrees angle. If we draw a straight line going across here to where YZ is, that would be our opposite side, right? Because this side is opposite to this 30 degree angle. If we draw a line going towards this side where 10 is, then 10 would be our adjacent side here. So 10 is adjacent to the angle. Now when you have opposite and adjacent, there is a ratio that comes to mind, and that ratio is tangent. So we know that tan theta is going to equal to opposite length over the adjacent length, right? And the angle here is going to be 30. So what we're going to do is to substitute these values. So therefore, it's going to be tan of 30 degrees is going to equal to the opposite side, which is YZ in this case, over the adjacent side, which is going to be 10 in this case. And if we transpose to make YZ the subject of the formula, all we need to do is to multiply both sides by 10. So our answer is going to be 10 tan of 30 degrees is equal to YZ. So our answer is going to be A in this case.